Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to continue on with part 3 of Fred's shoulder. Now, in the last build I had basically assembled all of this and I actually mounted it on the shoulder in its mounts. Since then I've removed it again. I've installed the ribbon cable, which will run all the way through. I've extended the servo. This one used to be connected in the shoulder itself, but because it's now running all the way through, I had to extend the wires. And one of the things I come across is these wires are just too close together without any form of protection. So we're going to fix that. We'll separate these out and put some heat shrink on. During some of the initial testing I did using a remote control transmitter receiver combination, I did manage to snap, and I've done it again, the wires down the bottom. That would explain why it's not working. So we're going to address that as well and repair those. So a few little repairs to do. The ribbon cable has a fair amount of length on it. Now this is not your standard AWG28 ribbon cable. This is actually AWG24. It's a lot heavier than your standard ribbon cable. I've gone with this to go down the arms, through the shoulders down to the arms, because it will be running all the servos. So I will no doubt use, this is a 12 core, so I'll use 4 of the cores for the I2C bus, including 3.3 volt and ground, and then I will double up the remaining wires for power. Okay, so first thing we need to do is actually fix this. This has obviously got problems. All 3 wires are actually broken. Awesome. So we'll have to get more heat shrink and fix that. Now, remember I said it had already broken one wire and I repaired it. That would be the short one. So this whole wire is going to probably be too short now, travelling around the path that it went. So I think we might just replace the whole of the wire with some fresh stuff. I'll use a multicolour ribbon while I'm at it. Now, in the intro you would have seen these parts being printed. This is a cover that slips over here and clips on, just to protect the innards here, and this gets glued onto here. Now I did have a bit of a problem with it lifting while it was printing, but I think we can get away with it. And what I'll do is I'll PLA weld this on the inside using the 3D pen. So that'll look reasonable when it's finished. It won't be so noticeable. I can always patch in a little bit down the bottom if I need to. So that'll look good when it's there. Now the way this was done, for those who are confused about the colour change, during the print I started out with the transparent filament. If you print it with some infill, you do get the opaque white, or the very white colour. To get the colour change, what I did was I paused the printer as it started to go to the logo and the text and changed out the filament to black and completed it that way. There is a way of doing it in Simplify 3D where you change out a line or insert a line as part of a script at the layer change, where you've worked out where your layer change is going to be. You have it perform a filament change, or an M600 in G-code. And it really does look effective. It's much better than colouring it in later on with a pen or something like that. So let's grab some ribbon and try and put all this together. I'm hoping to connect this to MyRobotLab and start testing it out so I can get the values I need to put into the program. So I'll just grab some ribbon cable. Okay, so I've got some ribbon cable. I'll make this a little bit longer than the last one. Now, coming out of the servo, we have 3 wires, red, green and yellow. Now the yellow is the center terminal on the pot. Ground is 0 volt and red's going to be our 5 volt or supply voltage. Now in the little bit of ribbon I've got yellow, green and blue. So what we're going to do is use the blue one in place of the red and just stick together with having the yellow and the green. That means at the pot I'm going to cross over the blue wire. And in actual fact I'll cross it over this way because I know that the green wire used to be attached to here and it was calibrated correctly. So for this I'll need a soldering iron. And I might grab a vise. Okay, so you can see that's soldered up. I've got good heat shrink all the way down in the middle terminal to keep everything separated. And the pot still turns quite nicely, so that will eliminate that potential issue. Let's look at the other end. Just grab some heat shrink. Now when you're soldering those up, you want to be quick because you don't want the heat to travel down through the wire and start melting your heat shrink prematurely. Okay, that looks pretty good. Okay, let's put the whole assembly back onto the robot and see if we can power it up. Just so you know, before I put it in, so I've run the ribbon cable through each of the joints coming up. Let me get some more light on the subject. That's a bit better. So I did put a keeper ring in there, and to be quite frank, I don't think it's worked very well. In fact, I think I might just pull it out. And I'll probably later on hot melt glue it into here somewhere to keep it out of the way. It may get shortened yet. Let's see how we go. So let's oh yeah. So the ribbon runs up through the middle, through here, through this tunnel, out on this side, and then ducks down between the servo and the frame to come out the bottom. I then added the wires from the 3 servos So this servo ducks around the back here. Whoops. That's come out. I'll have to make sure that's in before we put it back. Right. It's been extended inside, comes through and out through. That's this one on the outside edge, the left-hand side. The middle one, of course, being for the OMO plate, and then this one with a little bit of hot melt glue just to tack it in place to stop things catching. I then taped it as well as hot melt glue here to keep them all in place, and a couple more spots where I've taped it just to keep it all together. I've then added around the group of servos a label that says right hand side. This is the heat shrink label, and I'll put a link in the video for the label maker unboxing video I did. That's a 19mm heat shrink label, shrinks down quite well. And then on each of the wires for the servos, I've got the OMO plate, which is this one. I've got the shoulder, which is this one, and then the rotator, which is this one. This is, of course, assembly being all upside down at the moment. So this will come around and get connected into here, like so. So let's mount this back on the side. I haven't put this frame in here yet, and that's because I want to weld on the outer cover. But let's get this on. So I think I know what went wrong with the audio last video. I didn't have the microphone anywhere near close enough. So to get this in, you can see the nut is here. We're going to screw this in. I've got a wrong screw in there. I'll have to find a slightly shorter one than that. Okay. Okay, so to prevent accidental outages, I've just shut down the Raspberry Pi and then shut down all the power. Now I'm not sure where the best place to bring all the wires through are or is, but I'm going to come through this hole here. In case you're unaware, this one is actually the I2C bus from the back Raspberry Pi when it's connected. Currently it's not connected. That little label maker's coming in very handy. So up here I have the roll neck, the neck, and the top stump or top of stomach, which is the one that makes it rock side to side. So let's get this fed through. In the last build I did of Fred, I had a hole through up here somewhere. It's not present at this time, and I can't see where it previously existed. And I ran the wires over the top and through, which would have been a better way to go, but we'll see how we go with this arrangement. I'll just poke the ribbon down for now because I haven't used it yet. And I'll go with the OMO plate first. So that's connecting into output 0 of the PCA 9685. I'll then go with the shoulder into output 1. And the rotator into output 3. The plan when I do the left shoulder is connect 15, 14 and 13 respectively for the same wires. And we'll put the back cover back on, I think, so I don't accidentally drop it. Okay, let's start everything up. Okay, so I've now got the Raspberry Pi back up and running. So we'll launch a terminal, CD MRL. If we have a look in the directory, you'll see I've got the MyRobotLab program installed. I've also got the Fred program installed in here as well. So the Fred program consists of startfred.sh up here, and in this folder Fred. Inside the Fred folder the actual Fred programs, all written in Python, and below that level there's also the configuration scripts. In order to program the configuration scripts with the right values, we first need to know what they are, and the easiest way to do that is just to launch MyRobotLab as is. So Java -jar MyRobotLab.jar. Yeah, this is version 1.1.518 at the time of recording. Okay, so this is there's a lot of changes being made between this and the next version, but I've run into some bugs with the next version, so I'm not going to use it for this video. I'll use this 518. Now we know that it's 518 because up here it tells us the version number that we're running, which is 1.1.518. So we're going to go to runtime. Now, in the case of this build, I'm using a Raspberry Pi. So we click in service type and start typing in Raspberry Pi, it'll bring it up. And we'll call it a Raspberry Pi. And start the service. So we can confirm that that service is there. Now in the newer version, 1.1.523, it's laid out a little bit differently, and it also lets you look at the I2C bus and see what's connected. Now I can tell you from experience that there are 3 devices connected to this, one of which is using 2 addresses. So the device at hex address 0x40 is an Adafruit 16 channel servo driver based around the PCA 9685 LED driver chip. It's an I2C device. The next one is 0x41, and that's another one of those devices in his back, and the remaining 2 addresses are 0x68 and 0x70 are the I2C based NPU 6050, which will hopefully be working in the next version of MyRobotLab. So we can select the Adafruit driver, we'll call this back. Since we're only playing with the back, I'm only going to install the one. It appears down here. We select the correct controller, Raspberry Pi. Now on the Raspberry Pi you're using bus 1. If you are connecting this to an Arduino, change this to 0. The Arduino has a single bus starting at 0, whereas the Raspberry Pi has 2 I2C buses. The first one at a bus 0 is actually used for the micro SD card. So we're using bus 1 here. I do want to change this to X41 and then we can attach it. So that's now up and running. Let's go back to runtime. We're going to need at least 1 servo. Start the service. This will be attached to the back and it will be on pin 0. Now, be ready to kill the power when you do this. In fact, it's a good idea to move the arm part way up. I'll just switch and show you what I've done. So what I've done is just manually raise the shoulder a little bit. When you've got a whole arm hanging off that will actually fall under its own weight. Without the arm hanging off it, it doesn't fall so much. Now I will click attach. Then at the top tab we'll go into basic and we can start to move it. A little power to it. I think I got my wires back to front. Yes, I have got my wires back to front. Okay, so you've just seen what happens if you have got your wires crossed going to the pot. I have got them crossed, so I'm going to have to swap those 2 wires around. Okay, it would seem I've broken one of the pop pins. Probably all of the work I've been doing on it, flexing it back and forward. So I'm going to have to swap it out completely. Now, going back a little while on AliExpress, I did buy a heap of these. These are the same size. Their pins or leads are way too long. So we're going to trim these wires back. I think I'm just going to put it on the middle pin this time. I'll put it back to front. I wonder if the wire, that terminal had broken and that's what was giving me the erroneous reading. Right, so all the way down, we'll call 62. Wouldn't want to go any more than that. 119. Let's put it up back down. Okay, so we've worked out that 62 is a minimum and 119 is a maximum is the range that we want for that servo. So I've made a note of that on a bit of paper and I'll use that in the configurations within the Fred program. What we need now is another servo. So we'll call this one the servo shoulder. Servo shoulder will be connected to the back and to pin 1. And attach. So that's at 180. That's at 71, that's pointing straight down. And it will go back far too far. So I'm going to call 55 there our minimum. And our max at 180. So I'll show you what's going on there. So that's the minimum of 55. And the maximum 180. Okay, so we're going to just simply make another servo. Servo rotate, start the service, select our service, attach to the back, and this time will be pin 2. Attach, and again we can use this too. I think we'll leave that as is. So that'll be 0 to 180. That's 0. That's 180. And that's somewhere close to the middle. Alright, so we've got our pots installed. We've now got our calibration values that we can use in the thread program. So the next thing we need to do is finish putting his backpack on. Welding, this took a little longer than I anticipated, so I'll weld the this cover onto that brace and put all that together, and we will install these values in the thread program. To see when I do that on the next video, don't forget to click on subscribe and ring that notification bell. If you like these videos, don't forget to click on the like button. Join us by all means in the Discord server, where you can meet a lot of other like-minded people, and if you have any questions you can ask them there as well. I'd like to thank my 2 Patreons, Go Lucky and Elmorales45. Without their support, we probably wouldn't be getting these videos on a regular basis. So with that in mind, there is a link to both the Discord and the Patreon account in the description. And we'll see you in the next video.